Going to start recording now. So just to remind you, we have expressions. We've been working with lots of expressions. We know how to name them, we know what degree they are, that kind of stuff. And an expression tells you what to do with the numbers when you know what those numbers are. So 11a means whatever a is, you have to multiply by 11. Now an equation is when you have substituted a value into that expression and given it a value. So for instance, if I substitute into 11a, I might choose a is 4. Why is a 4? Be whatever it wants, yeah? Is 4 any special number in this case? No, I just picked it, right? It could be anything. But I said, so I'm going to substitute a as 4, which means I'm going to replace a with 4. That means 11a will equal 44. Okay? So I've given the expression a value. Now, when I've given an expression a value, it becomes an equation. So all these expressions have been given values. Right? You will notice that an expression has no equals sign. An equation, if you notice, equals. Yeah? So equation, expression with an equal sign. So it means it has a value. So what did we then go? Well, if substituting is given a value, okay, so we gave a couple of examples there. Solving an equation is you've been told the expression and you've been told its value, but you don't know what the number was that was substituted in, but we can work it out, right? And I gave you that thing on transom where we had the tomatoes and the apples and things like that, and we had to work out what one unknown way, right? So we had this process, and we've done this lots of times, yeah? This is the kind of thing in maths that we can't skip quickly through. You have to be able to do this in maths. Have to. And it gradually gets harder and harder and harder, right? More and more and more. So this is not something you can go, oh, I'll just do the next thing. It's fine. I can't do this. No, I'm afraid you kind of, we need you to be able to do this. So what we did is we were told that that equals that. That is an equation. It's a slightly harder one because it's got unknowns on both sides. But we went through the process of solving it. Do you recognise what's going on each time? No, I'm not thinking like that. We're eliminating from both sides. So this is the starting one. What was the first thing we did to be able to solve it? So we subtracted 2 t's from both sides. We can see that. That then simplifies to, or 2 t's plus 3 is 11. We did the same to both sides. We lifted it off the scales to keep it balanced. That's what the equal sign means, yeah? Equals means they are balanced. So we then eliminated and we simplified. What was the next thing we did that? We took away 3 from both sides and ended up with 2 t's is equal to 8. And then finally we divided by 2 and we found therefore t must equal 4. And we've done this before. We can do a check. How do we check? Yeah. So if t is equal to 4, 4 times 4 plus 3 should equal 2 times 4 plus 11. And we just check. 8 plus 3, that's 11. This is 8 plus 11. That's yeah. I did a common mistake there, didn't I? And you all went, yeah, that's fine.
I didn't notice that.
No, yeah, it's. Oh, well, you should have spoken up then. A lot of people then just, because they're just doing a quick thing, they just think, oh, 2 4s make 8. Okay? So what we're the mistake we made was it's 4 times 4, so that should have actually been 16, and 16 plus 3 is actually 19. Okay, now we know that 19 is equal to 19. That's good, right? We're happy with that. So that was my check. How do I know if I'm wrong? They're not. If I do my check and they're not equal, again, that's why I like maths, because I can normally decide whether I'm right or wrong before asking the teacher. Okay. So I said solving was when you're given the equation and you need to figure out what someone else has substituted in. Yeah? So we did another one, didn't we? So solve 3x plus 2 is 20, slightly easier one. Okay, we went through the process. Solaris, what was the first thing we did to solve this one?
We added
Added -2, I don't mind that, yeah. Added -2 or subtracted 2, yeah. Both exactly the same thing, so that's good. That simplifies to just 3x. And then we divided that by 3 because I've got 3 x's and I only want 1x, so x is 6. And we actually did our check this time. Look, 3 times 6, 18, 18 plus 2 should equal 20. It does, so I'm happy. Right. Just for your information, it doesn't really matter at the moment, but as you gets further on, sometimes there are equations where more than one number could have been substituted in. We say it might have 2 solutions or 3 solutions, and so on. Yeah. At the moment we're just dealing have one solution, but it will gradually get more. All right. I then introduced you to the concept of inverse functions, and I said to you inverse functions is basically just doing solving, right? It's the things that we do to unbuild the function. So what we talked it through was, let's consider, we consider this one, look. The first thing we did was work out how that function was made up. And we had to work out what operations were done in what order. And this one, y equals 2x minus 10, we think we put x in, the first thing we do is times 2, then we subtract 10, and if I'm unsure, what I do is think what happens if you,
reverse it.
not yet, what happens if you substitute in, yeah? If you substituted 3 in, what would you end up with? So 3 times 2 is 6, 6 minus 10 is -4. And we did another one, if I substitute 8 in, 8 times 2 is 16, 16 minus 10 is 6. Good. So, when we do our inverse function, we take the operations that were in the function and we have to do the opposite of them in the reverse order. So you can understand why the order that they happen is super important, right? So the inverse of subtract 10 is?
Add 10.
Add 10. The inverse of times by 2 is?
Divide 2.
Okay. And what we said was, if we're right, we should be able to take what was the answer, the y value, and put it into the inverse function and get back to where we started with. So like solving, yeah? And then what we've done, when we figured that out, we have to write it out. So this time we take the y, we add 10, then we have to divide everything by 2, the whole thing. As you can see, if I put -4 in, the add 10 has happened. So when I divide by 2, I've got to divide the whole thing by 2, yeah? And out of it comes x. So I can write it, y plus 10 divided by 2 is equal to x. Now, there's one thing which we do in maths, and it's correct, it's what we do, but actually in a lot of senses, and I'm hoping whoever you have in M4, will talk to you about this with an example. What we do is we swap the x and y round. So it actually, instead of becoming y plus 10 divided by 2, to write the inverse function, we swap the x and the y. Yeah? Just to write it down. In a real world sense, if we were going to do this as a function of cost, paying our plumber or something, actually swapping the x and the y doesn't make any sense. Not that doesn't seem right to do. However, when we are just writing inverse functions, that's what we do. All right? It's what is recognised as the right thing to do. But there are going to be times in the future where doing that doesn't make sense, and that'll be our criterion D thing to think about. Okay, so just to summarise before we'll do one more together and then I'll let you get on. To summarise, when we want to find an inverse function, we first have to really think carefully, how is this first function made up? What order does it happen? What are the operations? Yeah? If you get that wrong, obviously your inverse function will be wrong, right? Once you've worked out the operations and in what order they happen, you then do the inverse operations in the inverse order. Once you've done that function machine, you can write it out with putting y in, do this, y plus 10 divided by 2 gives you x. And the final step is to swap the x and the y. And that would be your inverse function. Any questions about it? Sense? All feel confident to be able to do it? And should we go through one example? One more? Okay. Are you on page 172 of your textbook? Yeah, let's be big. We could do it straight away together, but would you like the opportunity to try just for a couple of minutes, or are we just not ready yet? No? Well, let's do it then. Okay, so what we're going to do is we look at x, and we write down x, and we figure out what gets done to x in what order. So if I were to substitute a number in for x, let's just say x is 4, okay? What would I do with 4? So I would do 4 plus 6 and get the answer 10, and then what would I do? 10 divided by 5, and I would get the answer 2. So if I put that up here, it would be 4, then I would add the 6, then I would divide by the 5, the answer I get out would be 2. Okay. Now I'm going to just say, well, that's what I would do with x. So it would be x plus 6, then it's divided by 5. What comes out? What's the answer if I haven't chosen a number? What do we call it? It's a letter. What letter have we used? X goes in. What comes out? Y. Y can be found. Remember we said this yesterday and you were like, oh, y can be found by doing x plus 6 divided by 5. So how do I find y? Well, I take x, I add 6, and divide by 5. That's what it means. Okay, so now we're going to do the inverse function. So the inverse is put y in and do... By the way, I draw it backwards like this rather than doing left to right because that makes sense to me because I'm doing it backwards. Some people would say, oh, but if I just start y on this side and work that way, it could do, couldn't it? So I actually like doing, because I am doing the inverse direction as well, I kind of keep it consistent. What is the inverse of divide by 5? Multiply by 5. And then I subtract 6, and what comes out? X. Should we just do a confirmation that that's right? So if I put 2 in, what should I end up with? 4. So let's just check. 2 times 5 is 10. 10 minus 6 is 4. Sorry, I don't know why I put negative. So am I happy that I've got the right operations in the right order? Yeah, okay. So let's write it out as an inverse function then. So we do y times 5. How do I write that, by the way? Just put 5 next to it, like after it. You'll remember that, yeah? When we do algebra, when we multiply something we don't know, we say instead of y times 5, we do I want 5 y's. Yeah. What do I do next? Now I just subtract 6. Then I write it just subtract 6 like that? Yeah, because I always do multiplication first. What does that equal? X. Yeah. How do I complete my inverse? How do I complete my inverse function then? What is it? You switch. So we swap the x and the y, and it becomes 5x minus 6 equals, and that could go on the front if you like. Yeah. So the inverse function of this is y equals 5x minus 6. Yeah? How do you feel about that, everyone? Yes, no?